Welcome to Unit 3, Using Function Models. Basically, you're learning more about functions, which is a machine that shows the relationship between inputs and outputs, starting with 3.02, linear and quadratic systems. We have one goal here, but ultimately we're accomplishing two things. We're going to solve a system containing one linear equation and one quadratic equation in two variables. And we're going to do that algebraically and graphically. Are you interested in starting a business of your own? Well, today's the day. You've put a lot of thought into it and decided to create the newest and best video game system of all time. But where do you begin? What do you feel you need to figure out to be successful? You might be thinking marketing, advertising. What's the name? What are the financial situations looking like? What do we need to order? Are we hiring people? What are we using to make this? Well, we're going to figure that all out. And starting a business can be very stressful and exciting at the same time. So wouldn't it be nice to know when you'll begin to make profit? I would agree that it is. So we're going to figure that out. When will we make a profit? Okay, and profit is when your revenue exceeds your expenses. So revenue, most of you know that that's the total number of money you make. Everything you make, everything coming in. Expenses is everything going out. And how do you think expenses look when you're starting a business? They are typically pretty high. It costs money to make money. You've probably heard that. And how long is it going to take? Well, I don't know. In the real world, it could take several months up to several years. So hopefully we can figure this out and have a better idea of all of our hard work paying off. Is it going to be soon, later? Are we going to be in trouble, or is this all going to work out? Well, we're going to figure it out using these two functions. So this function we're going to call R is modeling our revenue, where X is the number of months that have passed since you began to invest money into your business venture. And your expenses is modeled by this function, calling it function E for expenses. So once again, the main question is, when will I make a profit? We're going to start to visualize that now by drawing a quick, simple sketch of what these lines will look like. Be sure to make them overlap because that's how they're going to look when we actually work this out. But right now, we're just getting a general idea. So see if you could do that. You should have noticed there's a positive quadratic, so opening up. And there is a positive slope on a linear equation. So as you look at this, think about where might be the moment where you draw even, where your revenue and your expenses are even, and meaning from that point on, if all goes well, you will begin to make a profit and start to really see your hard work pay off. Now, maybe you can see where that is right now, but if you can't, we're going to find it together by graphing. Okay, so we're going to solve the system graphically. Let's do it. Look at our first function. Revenue function is a quadratic. Do you remember what the parent function of a quadratic looks like? If you don't, you can always, for any function, plug values in and get values out. But if you remember the parent function, even better. So parent function of a quadratic has the vertex at the origin, and we know a parabola looks something like this. And our graph is pretty tall, so we're probably thinking this parabola will go up pretty high. And I mean, every parabola that opens up goes up forever, but maybe one of those points is a key point. Hint, hint. So this would be the parent function, roughly. The only point I drew accurately was the vertex. But now let's look at what we have. We do not have the parent function. Remember, parent function for this would just have the x squared and nothing else. So what does that plus 4 do? Well, that is elevator V, meaning every single point moves up. Well, we only really graphed the vertex properly. So that's the only point I'm going to graph right now because if we're going to start a business together, we need to do this accurately and specifically, right? We don't want to just say, oh, I don't know, we'll just keep doing what we're doing and hopefully it all works out. Maybe kind of it looks like this. I think this is what's going to happen. That's not the best approach. We want to get accurate. So let's do it. We're going to find a few more points for this function. So we take our revenue function and pick some values. Let's just go, I'm going to go with 4 and 6. You could go with 2 and 8 or 2 and 4, whatever you want. You could do them all. I'm probably not going to do all of them. Here is 16 plus 4, that's 20. So we have another point at 420. And we know the axis of symmetry goes through the vertex. So there's also a point at negative 420. But this graph goes pretty high up, so I'm going to pick another point to see more specific points higher up. So this will give us 6 squared, 36 plus 4, that's 40, and that is quite a ways up there. So over to 6, up to 40, and axis of symmetry, 3 away, 3 away, boom, boom. We have some key points here. So I'm going to connect these dots as best I can. There we go. There we go. All right. We are well on our way. So this is our revenue function. Maybe I'll label it R of X. And it's time to graph our linear function and see what happens. Okay, I see a y-intercept of 10. So 10 right there. And then a slope of 5. So 5 over 1. Positive rise over positive run. So up 5, right 1. And we're going to keep doing that until hopefully we find a specific point on this line or maybe on this side where it touches. So let's start just going down to the left. So if we're going up and over as we go to the right, we go down and to the left as we go to the left. So we go down 5, left 1. Look at that. Already found a point. Where is that? Negative 1, 5. And that is one of the solutions to the system because remember, solutions are anywhere, all the places your graph lines touch. Now that line wasn't too accurate, so let me do it one more time. Okay. But we need the rest of the line and we want to be specific. So here we go. Up 5 over 1. Be careful. This graph is in units of 2. Okay. 15, we need to go up 5 to 20 over 1. Up 5 over 1. 25, up 5 over 1. We're still reaching. We're still trying to hit a point over here. Okay, 30 up to 35 over 1. Oh, is it going to land? Let's see. Up to 40 over 1. Beautiful. We have another point. And I'm going to get a nice straight line for us so we can see this very nicely. So give me 1 second. I'm going to get rid of this and allow us to see a nice clear line here. Here we go. So through that top point, and we had a bottom point down there. Oh, this needs to be over a little bit. Getting it as accurate as possible. There it is. So, luckily for us, this point, 640, didn't just so happen to be a point we found on the parabola, but also on the straight line. Do you know what you just discovered? Several things. You discovered when you're going to begin to make a profit. So let's take a look. If we're looking at this graph, revenue, your revenue is going down. You're spending, 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 and you're just bleeding out money. And then you get here and you are at your ultimate debt, right? You've spent all the money, your cost is up here, your money's all gone. Hopefully, this all works out. This was a big investment. Let's see what happens. Well, here you're starting to make more money, and the gap is getting more narrow between your cost and your revenue, between your expenses and your income. And it's getting closer and closer and closer till the final point where you are jumping for joy because right here you are now not in debt. You are now broken even, and now you're going to begin to make profit because we see the parabola now is above the straight line, right? This will continue to go that way, and this will continue to go that way, and you will be in good shape. And you also found the solutions to the system. The solutions are the 2 points where the graph intersects. So that is how we found where we're going to make a profit or when. So after 6 months, could be worse for sure. Okay. So that's hopefully making us feel a little bit better. 6 months and we'll be good to go. Okay. So we're going to solve this same problem algebraically. I'm showing you here graphically to keep that fresh in your mind and also to compare. When we work this out algebraically, are we going to get these same solutions? Well, we're going to follow these steps right here to get that done. Let's see what happens. When you are solving a system of equations algebraically, first set the two functions equal to each other. Because if you look at a graph, aren't the points they intersect at the same exact point right here and right here? So that's where they're equal to each other. Okay? Step 2, use inverse operations to make one side 0. So we can move everything to the right or everything to the left, but be very careful. If the quadratic is positive, you must keep it positive when solving. And our quadratic is positive. Okay? This is what I'm trying to say. Let me show you very clearly. If I decided, hey, I'm going to move everything to this side. You can absolutely do that and everything will be all good, except it's going to be a little more work. And you notice here a negative parabola, which means if you don't remember right now to make this positive, you're going to get the wrong answers. So what you would want to do at this step, multiply everything by -1, all these signs would change. Okay? But in order to prevent that and make our lives a little bit easier, why not just move everything to the left, keeping the x squared positive? So move the 5x, move the 10, we get this and this and this. Positive quadratic, don't need to do anything else except move on to number 3. factor and find solutions like you've done so many times. And how do we do that for a quadratic with a leading coefficient of 1? The x method. So we draw our x, we put a times c on top, b on bottom. What two factors of -6 add to -5? Well, you could start with anything you want, 2 and -3. Those will not add to -5. So you could try different things, but I believe it's -6 and 1. Let's see. -6 times 1, -6 plus 1. We got it. So we write out our factors. X minus 6 times x plus 1 set equal to 0. And take each factor, set equal to 0, solve for x. X is 6 and x is -1. Are those the x values we had on the right? Amazing. So we know we've done this correctly so far. But remember, we're just using the graph to help check things right now. Oftentimes, you won't be given a graph. So how do we find the y values right now? Well, we plug them in. But which function do we plug them into? It doesn't matter, right? Because these points are in the exact same place for both lines. So you can pick either function. Okay, I'm not going to show all the work, but I can easily explain. I'm just going to work with the top function, r of x. If I plug in 6, I get 6 squared, 36, plus 4, 40. So I'll have a point at 640. Boom, there it is. -1. -1 squared is 1, plus 4 is 5. There it is. There's my 5. Congratulations, you did it. You found out how long it's going to take to make a profit, and it looks like you are going to be successful after all. Now, remember, this quadratic we saw had a leading coefficient of 1. Please, please, please remember if the leading coefficient of a quadratic is greater than 1, you have to use the quadratic formula. Okay? Remember, identifying A, B, and C is super important. Those are the coefficients and the constant. And let's go back to this graph one more time. When you look at this, you see how many solutions? 2, right? Do you think that's always the case? What if these lines moved around in different places, different slopes, different y-intercepts? Well, there's different options, and you see them right here. We just looked at a situation where we had 2 solutions, 1, 2. But sometimes there's only one solution if the parabola just comes down, touches the straight line, and loops back up. This is also a very interesting graph and situation that we're going to focus on more this unit. So just a heads up on that. But you might have a situation where nothing is touching. That means there's no solution at all. Okay? And this would be an unrealistic uh, business model because you never have more profit before you don't have profit before you even start your company, which this would show. You have more money up there. But graphs are used to figure out all types of things in the real world. Okay, not just money, but I think that's one thing we can all relate to and get into a little bit. Okay, so you can't have 0, 1, or 2 solutions. That's it. There's no other options. And with that said, here's an exit ticket. Be very careful. We haven't solved a problem exactly like this, but I'll give you this clue. We had 2 functions before, right? R of X and E of X. And what do? We set them equal to each other, right? And we could do that because R of X is the same as what? And E of X is the same as what? Y. So keep that in mind. If you want to see it either like this or like this, that's what you need to make sure of first. And let's see how you did. That clue meant you need to solve for y first. Okay, so for this equation, you need to move x to the other side and make y positive. There we go. Now we have what we want. Now we can set them equal to each other. So we take everything on this side, x plus 1, and everything on the right in our second equation, set them equal to each other. This quadratic was positive, keep it positive, move everything to the right then. Quadratic leading coefficient of 1. And now we try the x method, but something interesting happens. It doesn't work. That's possible. So you need to double, triple check your work to make sure there were no mistakes because remember, there can be 0, 1, or 2 solutions. And if this doesn't happen, that means there are no real solutions. So if that's an answer choice, that's the one you want to pick. If they're asking for imaginary numbers, then you would want to use the quadratic formula and work it out. But for this one, all we want to know is if there are real solutions, what are they? And there's not. So we're done for today and one step closer to learning everything we need to learn in this unit. See you later.